Hello everyone. In this video, I'll be covering polar coordinates, and along with the introduction to polar coordinates, I'll also cover the transformations, that is from rectangular to polar and polar to rectangular. And I can assure you that they will ask you at least 2 to 3 questions in your MCQs about polar coordinates in part A itself. I don't know how many can they ask in part B. And again, it's an important topic, so pay attention. Let's move ahead. Now, until now, you've only been familiar with the Cartesian coordinate system, which is the regular x-axis and y-axis one, where the x-coordinate gives you the magnitude and direction of the horizontal movement. It could be this way or this way, and the y-coordinate gives the magnitude and direction of the vertical movement, which could be either this or this, or this or this. So that is what you know until now. But there are a few other coordinate systems, like one is a complex plane, another one is a polar one, which we will be learning today. Now, in the polar coordinate system, a point P is located relative to a fixed point O. So the fixed point O that we have here is called the pole, and we have a horizontal ray whose endpoint is the pole, as I said, and it is known as the polar axis. The horizontal line that we have is called as the polar axis. And we have a directed angle called theta, whose initial side is over here, which means it has a common vertex, and it is a ray which originates from that vertex. Now, polar coordinates are defined as an ordered pair, r comma theta instead of x comma y, such that r represents the radius of the circle and theta represents the measure of the angle. It also depends on the sign of the radius and the angle subtended. For instance, if I gave you 3 comma pi by 3, it means that if I have my polar axis right here, I'll first move the radius like we do with the x-axis, with the x-coordinate. Since it gives me a radius of 3, I'll move, let's say 1, 2, 3. I'll move right here, and then it gives me an angle of pi over 3, which is in degree 60. So it'll be something like this. It'll move right over here. So this point right here, which has a radius of 3 and theta of pi over 3, is right here. That is how you define a polar coordinate. Now I'll explain the difference of the sign of the radius and angle. Now, if we had the regular Cartesian plane, we know what would happen in the case of a negative x and a negative y. If I had my axis like this, I know that a negative x would take me in this direction and a negative y would take me in this direction. But what do we do in case of a polar coordinate? I'll first talk about the negative radius, the radius being negative. So if you have the radius negative, then you have to first locate r comma theta. We take the absolute value. For instance, if I were to ask you plot the point negative 3 comma pi over 3, which we just did but with a positive sign, then you take your axis, you take your polar axis, you take your pole, and as I said, you'll first map this point, the absolute value of the radius and theta. So as I demonstrated, we take 3 radius and we move pi over 3 to get this point right here. This would be pi over 3 and this would be 3. Now, to get a negative radius, you'll just flip this around. I'll flip this to get this one, which will have a magnitude of 3 but in the opposite direction. So wherever you have it, just flip it vertically along, the normal. So I flip this thing right here to get this, and now this point that I have right here is negative 3 comma pi over 3. I hope that was clear. If I give you negative 5 comma pi over 2, then in this case, if I have my polar axis like this, I'd first plot the point 5 comma pi by 2, And since pi by 2 is 90 degrees, it would go upwards, and I'd have a point right here, which is of the magnitude phi. And I'll now flip it about its normal. I'll flip it around this line over here to get this one. I don't have a lot of space, which has a magnitude phi. And now this point after flipping becomes negative phi, comma pi over 2. I hope that was clear, the part where you flip the radius if you have a negative one. Now, what in the case if I have a negative theta, alright? You might think, how can we have a negative theta? But yes, we can have a negative theta. For instance, if I tell you 4 comma negative pi over 3, how would you plot that? Now, you do the same thing, but you move anti-clockwise, or pardon, you move clockwise. If you have a positive angle, you move anti-clockwise. If you have a negative angle, you move clockwise. Now, if I were to plot this point 4 comma negative pi over 3, I'd have my axis. I'd move 4 as I'm supposed to right here, and instead of going pi over 3 in this direction, I'll go pi over 3 in the clockwise direction to end up somewhere here. You still denote it as pi over 3, but it tells you which direction you go, and this point would be 4 comma negative pi over 3. Similarly, if I ask you negative 4 comma negative pi over 3, then again take your axis. I'll change my color. You go first, you plot the point absolute value of radius comma theta. So I'll go right here, which is 4 units. And again, if I have a negative sign, then I move clockwise. I'll move in this direction. I'll go somewhere here. This is my point 4 comma negative pi over 3. But we're asked to find negative 4. So I'll take the perpendicular and I'll flip it around to get this one. My lines aren't the most straight. So this point that you have right here is negative 4 comma negative pi over 3. I hope the flipping anti-clockwise was quite clear to you. Take note of this and let's move ahead. Now the first conversion that you have here is a very easy one, and pray to God that you get this instead of the other one. To go from polar to rectangular, you have a very simple relation, which is the x coordinate will be r times cos theta and the y coordinate will be r times sin theta. I'll show an example. If I'm given the polar coordinates r comma theta to be, let's take 3 comma pi by 3 again. If we're given 3 comma pi by 3, then if I want to find my x coordinate, then I'll have the x coordinate is equal to the radius, which is 3, times the cosine of pi over 3. And we know cosine of pi over 3 will be equal to 1 over 2. So we have x is equal to 3 over 2. Now if I were to find the y coordinate, I'll have y is equal to 3 times sine. My sign went horrible. Pi over 3. Now y would be equal to, now we know that sine of pi over 3 would be root 3 over 2. Root 3 over 2. So I'll have my y coordinate as 3 root 3 over 2 and my x coordinate as 3 over 2. I hope that was very simple and straightforward. Remember one thing and pray that you get this instead of rectangular to polar, which is very difficult, but we'll have to move to that. Now I have with me here the conversion from rectangular to polar, which has a few cases. Now, a polar coordinate has two parts. We know we have the radius and the angle, and there is a very simple relation for the radius, which is root of x squared plus y squared, which comes from the Pythagoras theorem. Irrespective of whether your x and y are positive or negative, you apply this formula to get your radius. Now, the theta or the angle, polar angle, is something That's a bit tricky. And it actually depends on the cases. If you have x and y positive, then you have a different formula. If you have one negative, one positive, you have a different formula and stuff like that. Now, the reason why we have different formulas is that I'll draw the Cartesian plane right here, is that our goal is to fit everything right in this first quadrant. So if you have a point right here, your goal is to bring it over here. A point here, you must bring it here. And that is the reason why we add pi, add 2 pi, subtract this angle and stuff like that. So if you have x and y positive, both of them positive, which means the angle already lies in here, then you only have the inverse tan of the absolute value of y over x, and you do not have any extra pi or 2 pi additions or subtractions. If you have it in your second quadrant right here, you have this case where you add pi and subtract the tan inverse of y over x to bring the point right here. Similarly, if you have both of them negative in the third quadrant, then you add pi and even add the tan inverse, since if you take a pi, you end up here, and then with the extra tan inverse, you get all the way there. And similarly, if you're in the fourth quadrant, then you subtract the tan inverse and add 2 pi to fit your angle right here. So the main objective of adding and subtracting pi's is to get your point right in here, and accordingly you'll have to work with the formulas. Take a screenshot of this or remember this, the four different cases, and this one is quite simple. Now I'll move with two important examples which will make everything clear. Now we're given the x and y coordinates to be 3 and root 3, and we're supposed to convert them into r comma theta. Now I recommend you, without analyzing the signs and all, you first take out the radius. We know that the radius is root over x square plus y square, so radius will be 3 square is 9 and root 3 square is 3. So this will be root 12, and root 12 will be 2 to 3. So our radius is 2 root 3, but what about the angle theta? Now, if you look at the case that we have here, we have both of them positive, and when we have both of them positive, we have the first case, which is simply tan inverse of y over x. So I'll take tan inverse tan inverse of y over x to be r theta. Now we know y over x in this case is just root 3 over 3. And when is tan root 3 over root 3? Well, we know tan is root 3 over root 3 at pi by 6. So our final coordinates will be 2 root 3 comma pi over 6. I hope that was quite simple and straightforward. Now I have the last part of the video, which is example 2, in which we have the coordinates 2 comma minus 2. Now, as I mentioned earlier, the first step would be to evaluate the radius. We know the radius is the root of x squared plus y squared. In this case, 2 square is 4, and negative 2 square is 4 again. So this will evaluate to root 8, and root 8 is 4 times 2, which means 2 root 2. So our radius is 2 root 2. What about the angle? Well, we have x coordinate to be positive and the y coordinate to be negative. And if you look at the fourth point that we have here, which is for x greater than 0 and y less than 0, we have theta is equal to 2 pi minus tan inverse of y over x. So we'll use that formula. We have theta is equal to 2 pi minus tan inverse of y over x, and the absolute value. I want you to make sure that whenever you're using them, all of them have the absolute value of y over x, which is something very important you should note. Now we'll have theta is equal to 2 pi minus tan inverse of the absolute value of negative 2 over 2. Now we know negative 2 over 2 is negative 1, but since we're taking the absolute value, we have theta is equal to 2 pi minus tan inverse of 1. tan inverse of 1. Now, when is tan inverse 1? Well, tan inverse is 1 at pi over 6, I suppose, yeah. Pardon, pi over 4. So we have 2 pi minus pi over 4. If we take the LCM, we have 8 pi minus pi over 4. So I have 7 pi over 4. So my final coordinates would be 2 root 2, comma 7 pi over 4. I hope these examples, conversions, and introduction to polar coordinates was clear. If you have any doubts, questions, make sure to drop it in the comment section below. I'll reply as soon as possible. Until then, I'll see you soon. Thank you. Have a good day.